Okay, we're moving on to number 8. So we're bringing in a kind of new dimension of this, as often happens in these questions. We are going to have to go back one more time, but for now this is kind of a bit of a fresh start. So if you had, say, lost your way on the earlier bits, this is an opportunity to sort of get marks without relying on previous bits. The company is considering making bags. Research shows that a model for the profit each day, profit in dollars, from the sale of B bags is P equals B squared minus 30.5B minus 65. On the axes below, sketch the graph of P equals B squared minus 34.5B minus 65 for B is between 0 and 35 inclusive. So you've got some axes. What we don't have is any y details apart from this 0, so it's going to take some window work, but we certainly know that we're looking between 0 and 35. That is certainly our x min, x max, and it could probably be our y max as well, but I think I'll make it a little bit bigger than that. So if we go to graph and put it in, obviously we're not going to put a b in, so we're going to use an x, so it would be x squared minus 30.5x x minus 65. Like that. Have a look at it. F6 to draw, and I need to adjust my window quite a lot, so Shift V window. As I was saying, I definitely want to use 0 as my x min and 35 as my x max, because we've been asked to sketch it for this fixed domain between 0 and 35. So x min 0, max is 35. Skip the scale and dot. Y min, that's what we don't know. So, but looking at it, we're going to need a bit more room on the minimum than on the maximum for sure. So I would imagine I'm going to have to come back here in a second, but if I go to, I don't know, say minus 30, something like that, could be way out. I don't know. The max, well, I certainly don't want to be going up to 160. In fact, I don't really want to be going a lot beyond 0. So I'm just going to go up to, say, 5, and I might even change that. So let's have a look. So that does not look brilliant, because I need to see, I'm looking for a parabola. This is a positive quadratic, so I'm looking for something that does that. I certainly can't see that at the moment, so I need a definite change of Y window. View window, so X min max. Y min, so I'm going to make that a lot smaller, so at minus 200. Let's have a look at that. If we draw that, I'm getting closer now. I can nearly see the whole curve, but I'm going to have to go down further. So Shift V window. Let's go to minus 300, and hopefully we'll see the whole curve. Okay, so that's more like it. So now I can sketch that. It looks like this minimum's kind of central-ish, maybe slightly to the left, but I'm going to put it somewhere around here. The minimum I have, I could do with knowing where these points are really for scaling, and plus you get communication marks. I'm going to need some numbers on here to scale the y's. So this is a y-intercept, so let's find that. So Shift G solve, y-intercept. If you're on a TI, you'd just trace and type in an x value of 0. So this is telling me that is minus 65. Right, so that value there is minus 65. So if I draw that here, that can be minus 65. This will get me some communication marks. I know I need to go through that. And then I also want to know this x-intercept there. So Shift G solve. X-intercepts are called roots. So that is at 32.5. So somewhere over here, 32.5, something like that. And then, so I assume it probably goes up a bit. in which case I probably do want to see a bit more of the window. So if I just shift my view window so I can see a bit more in the positive, maybe if I go up to say 20, I might just be able to see the end of this. Yeah, so I can see it just goes up to here. So I'm going to come up to somewhere like that. Okay, so now I'm ready to draw this. So a nice smooth curve down to the minimum, up to here and off the screen. Right, I probably might put, again, just for communication, I put my window down to 300, so minus 300, wasn't it? So minus 300. I'm not necessarily saying at that point it's minus 300. I don't know what that is, but looking at this question, I'm going to have to do that anyway. So I think that's probably enough. It's got the right basic shape. And if I just tell you the mark scheme, you need a parabola, the correct way up. So that's my quadratic like that. Negative y-intercept. We have a negative y-intercept and an x-intercept between 30 and 35. Well, it definitely is. And we've labeled it, so we'll get some communication marks. Right. Part B. Find the minimum number of bags the company needs to sell each day in order to make a positive profit. Now remember, this is the graph of number of bags sold on the x-axis against profit. So profit is positive when it is above the x-axis. So actually it's 32.5 bags. So that's going to be 30. You can't sell 32.5 bags. So that means they need to sell a minimum of 33 bags in order for this to be positive. Right, the greatest number of bags the company can make is 80. Find the profit that the company will make each day when it sells all 80 bags. So 80 is obviously not on this graph, but it doesn't really matter. We have an equation for profit. Now you could continue the graph. The disadvantage I would have, when I say continue the graph, I mean on the calculator, change the view window. The disadvantage is you wouldn't necessarily get a chance to show any working with that, and you do get communication marks on this. So when somebody's marked all your actual answers, then they look back through and look for evidence of good working and good mathematical communication, or sometimes it's written communication when you're about to explain things. So what we're going to do here, I'm going to just plug in B as 80 into here. So if it sells 80 bags, the profit will be, P is going to be, well, it's B squared, B is 80, so 80 squared minus 30.5B, 30.5 times 80 minus 65. And I'm just going to work that out. So we go to the calculator. 80 squared minus 30.5 times 80 minus 65. And that gives us a profit of $3,895. 3895. Have to. Right. So that is number 8. The final question on here is quite tricky, as you would expect from a modelling paper. It kind of brings a few things together. So the final question, number 9. The company decides to make 80 bags each day. So they've got ahead with this number. It's quite handy because we've already done the calculation. For every 2 bags it makes, it has to decrease the number of pairs of style X shoes by 1. The shortage of material for making shoes is the same as in question 7. There is no shortage of material for making bags. Find the greatest, so part A, we need to find the greatest number of pairs of shoes of style Y that the company can make. And B, show that the company's profit each day has increased. So I think, well, we need to work out what is 80. It says for every 2 bags, so 2 bags made would be 1 less pair of style X, right? So if it's 80 bags, well, that is going to be 40 less pairs of X. So we need however many pairs of style X we were making before, we need to reduce that number by 40. So we need to find out what that is. And if I go to question 7b, remember we need to do a lot of flicking around it. If you go to 7b, we had this new constraint, because this question, it does say the shortage of material for making shoes is the same as in question 7. So if I look at question 7, I can see that we made 80 pairs of style X, right? And that was after looking at the graph. We drew the new line in, and we realized we made 80 now. So we're going to have to reduce this number by 40. So we can make at most 40 pairs of style X. So that means the number of X needs to be less than or equal to 40. So there are different ways to do this, but we've been getting on well with the lines so far. So what I'm going to do, I'm going to go back to the original graph, and I'm going to draw the line X equals 40, and then I'm going to shade the unwanted region. So I'm going to go on here. So just one more constraint, as if there wasn't enough already. So I'm going to draw X equals 40. And that is a simple enough line to draw, just straight line up from 40 like that. And we want the unwanted region. Remember, we need to draw X is less than or equal to 40. So the unwanted region is to the left, less than 40. So we're going to shade, the wanted region is to the left. We're going to shade the unwanted region, which is this side of the 40, right? So we're going to shade this side. So now we have this new feasible region in here for the final bit, and we're looking for the maximum profit for the shoes with all of these constraints, including this one new one. And the maximum, remember, it only happens on the edge. It's going to be this point here. So it's going to be around there. So that's what's going to tell us our X and Y. So it looks like it's still on the line X equals 40. We've got to work out a Y value, or get a Y value. So this is 70 here, so 72, 74, and that's somewhere between 74 and 76. I'm going to call that 75. So I reckon we are going to make 40 pairs of style X, 75 pairs of style Y. So let's go back to that. So we're going to make 40 pairs of X and 75 pairs of Y. So the first question, the first part of this question was just asking, find the greatest number of pairs of Y that we can make. The answer is 75. And now the final part of this, show that the company's profit each day has increased. Well, we already know that the profit from the bags is $3,895, and that is profit. So we don't have to do any other calculation for that to turn it into profit. So we're going to use this number, but we need to find the profit from the shoes as well. So we need to go digging around. And if you remember, go back to question 7, because anything earlier didn't have the material constraint on. So for question 7, we had 80x plus 55y. That was our profit. Actually, sorry, that was exactly the same profit equation as before, profit expression. So we can still do this. It's 80x plus 55y with our new x of 40 and y is 75. So shoe profit equals, so it's 80x plus 55y equals 80 times x 40 plus 55 times 75. Go to our calculators. 80 times 40 plus 55 times 75. So the profit from the shoes is 7325. 7,325. So total profit for the company is going to be the bag profit, which was 3,895 plus the shoe profit. 3,895 plus the shoe profit that we just worked out, 7,325, and that is, if I just add on 3,895, that gives us a total profit of $11,220. So to show that this has increased, all we really need to do is show that that is a bigger number. So if we compare the old profit before they started making bags was, once we had the material constraint, it was 7,775. So it's clearly a bigger number. So 1,1220 is larger than 7,775. We've not been asked how much more of a profit or percentage or anything like that. We've just been asked to show that it's larger. And I think that's probably enough. So that is the end of the first modelling section.